Asteroid 2024 YR4 has suddenly become one of the most talked about objects in the solar system, not because it threatens Earth, but because updated scientific models now show a small chance it could reach the Moon in 2032. That single possibility has pushed researchers to explore advanced planetary defense ideas. In this video, we uncover how scientists detected this risk, what a lunar impact could mean, and how experts plan to keep our space environment safe. The story of 2024 YR4 begins like many other new asteroid detections. A faint object captured in automated sky survey images and logged for routine tracking. But the real twist came after astronomers gathered multiple nights of follow-up observations. Each new measurement added a point in its trajectory, and once these data were fed into orbital refinement models used by NASA and ESA, researchers noticed something unexpected. Instead of drifting safely through deep space, the asteroid's projected path aligned with a narrow region near the Moon's orbit. Updated calculations published through Science Alert and Hindustan Times highlighted a probability of roughly 4% that YR4 could cross the Moon's position around late 2032. While that percentage may seem small, it is unusually high for a Moon-intersecting trajectory and enough to prompt deeper investigation. Scientists use statistical techniques such as Monte Carlo simulations to test thousands of potential future paths, each slightly altered to account for measurement uncertainties. In many of these simulations, YR4 misses the Moon entirely, yet a noticeable cluster shows a direct lunar encounter. This matters because the Moon is no longer just a distant companion, it's now an active destination for scientific missions and future exploration. Multiple countries have orbiters, planned landers, and communication arrays positioned around it. Even a rare event like a lunar impact must be carefully studied to understand its potential effects on the increasingly busy orbital space around the Moon. These refined calculations form the foundation for everything that follows. What a lunar impact might look like, and what scientists can do if necessary to gently redirect the asteroid. If 2024 YR4 reached the Moon, the event would unfold very differently than an impact on Earth. Without an atmosphere, the Moon cannot slow down incoming objects, meaning an asteroid arrives at full cosmic speed. Upon contact, the energy would excavate a new crater and release a plume of debris composed of rock, dust, and vaporized material. The size of the plume depends on the asteroid's mass, speed, and composition, but even modest objects can generate dramatic ejecta in low-gravity environments. Lunar impact studies from NASA's Lunar Reconnaissance Orbiter show that debris from even small meteoroid strikes can spread across vast regions. Larger impacts can push fragments high above the lunar surface and in rare cases beyond lunar escape velocity. If material escapes into cislunar space, it could slowly drift into regions used by orbiters and satellites. With projects like NASA's Gateway Station, China's Keiqiao relays, and various planned landers, the space surrounding the Moon is becoming increasingly active. A fresh cloud of debris could require mission planners to adjust orbital paths, delay operations, or recalibrate mapping data. Dust also behaves unpredictably on the Moon, sometimes clinging to surfaces due to static charging. These particles can interfere with optical instruments or navigation systems if they drift into active operational zones. From a scientific perspective, a new crater would offer fresh geological insights, yet even beneficial data doesn't outweigh the need for preparation. Understanding the potential consequences allows agencies to proactively plan for safe spacecraft positioning and ensures that future infrastructure remains protected. These concerns naturally lead to the question: if YR4's path becomes more certain, how could scientists redirect it using today's most advanced planetary defense tools? When evaluating how to gently alter the trajectory of 2024 YR4, scientists consider a range of planetary defense tools already studied for Earthbound scenarios. The most familiar method is the kinetic impactor, demonstrated by NASA's DART mission, which redirected the orbit of the small asteroid Dimorphos in 2022. This technique relies on transferring momentum by striking the asteroid with a high-speed spacecraft. However, for larger or fast-moving objects, especially those detected on relatively short notice, researchers analyzed more powerful alternatives. One of the most efficient options is known as a nuclear standoff detonation. a concept referenced in news summaries of a planetary defense study reported by Science Alert. In this technique, a device would be detonated at a calculated distance from the asteroid. The burst of energy vaporizes a thin layer of material on the asteroid's surface, and the expanding vapor pushes the asteroid slightly off its path, acting almost like a natural thruster. This method is not about destroying the asteroid, but about achieving a gentle, controlled shift over time. The approach remains compliant with scientific guidelines because it is analyzed within the context of safety, transparency, and global cooperation. Simulations allow researchers to determine how much energy would be needed and how far in advance a mission must be launched. Various models test the asteroid's rotation, density, and shape to ensure a predictable outcome. These studies help scientists compare multiple deflection strategies and identify the most reliable option with the least risk. What makes this scenario so significant is that it demonstrates how dynamic the Earth-Moon environment has become. As more nations and companies expand their presence near the Moon, protecting this shared space becomes a collective responsibility supported by science, collaboration, and early planning. Thanks for watching. This asteroid may never hit the Moon, but the research around it shows how quickly our space environment is changing and how urgently we need reliable planetary defense tools. If you enjoyed this deep dive, make sure to like, share, and subscribe for more space stories that reveal just how dynamic our universe really is.